What's up, class? Evans here. Today's assignment is pretty easy. I just need you to take some notes about alternative views. And if we ever get the chance to come back to the school in 2 weeks or so, hopefully we get a chance to use Inventor with some of these views. So, alternative views. There we go. So these are the three main alternative views. So it says at the top, in some cases, orthogonal projections, which are the multi-view projections, the top, the front, the right, and if needed, there's the left, there's the bottom, and there's the back. So those 6 orthogonal projections and the 3D pictorial, if that's not sufficient, then you might need some other views. So let's look at the 3 different types. There's section views, which is used to show the inside details not apparent to the exterior of the part. So something where there's a lot of inside that's just as important as the outside or more important. So section views is like an inside view. And these 3, you should definitely get these 3 definitions down in your notes. And you're going to practice drawing these in your assignment for next week. Auxiliary views, this one's harder to explain. This is used to show features that are located on an inclined surface in like the true size and shape of something. Detailed views, the last one, this is like a close-up view of something, kind of zoom in to show smaller details. That's the purpose of the detailed view. If you haven't finished writing them, pause the video, get those 3 written down, and then we'll move on to the next slide. So a section view, this provides a view of an object as if it were cut by a saw. So if you look at this example here, this is like a little glass insert that sits on the top of a toy car, like it's supposed to be the windshield of a truck kind of thing. So it's cut so that we can see the inside of it. If you look, and let me move my face out of the way. If you look here, this is the cutting plane line here, saying that's where it gets cut. So this right here is where it's cut, and then you can see these diagonal lines here. This is showing that that's like a saw blade marks, if you will. Now, don't get confused and think, oh, so it actually is cut. No, it's just as if it were cut for the example of the drawing. There are 3 types of section views that we're going to cover here. The 3 main ones are a full section, a half section, and an offset section. The cutting plane line is going to pass fully through the part, and the part of the object behind the cutting plane line is then removed, like pulled away. So here's an example. So from this view here, all we see is a bunch of circles. So imagine that it's cut right in the middle of those circles. That half of the part is removed, and then we turn and look at the inside of it. So from the outside, all we would have seen is hidden lines and then the outer edging. At least if we cut plane it or do a full section, then all the hidden lines are at least now object lines. And then you see these diagonal lines. These are the section lines showing where the material is that was cut. So that is a full section right there. Remember, a section already means it's cut in half. So a full section means it's fully cut all the way through. Keep that in mind for this next one, which is a half section. It's typically used on symmetrical parts to show the inside of it. A quarter of it's cut away. Remember, half already means, section already means half. So if you're doing half of a section, that means you're doing a quarter. So take a look at this example here. The cutting plane line goes half the way through because that's a half section, and then it exits out. So you're cutting out a fourth of it. And when you look at the half section view, you see half of it from the outside and half of it from the inside. You could use a half section view on anything that you wanted to show internal features, but it's best used for symmetrical parts that are like radial symmetry, something that is like circular, like a cup. Anything circular, a half section makes the most sense for that. Notice that on the half section, it only has one arrow as opposed to two arrows. An offset section, this is when you have different features that you want to show the inside of, but they're not lined up. So this is an example here where you have this odd bracket bowl plate thing, and it's got a hole here. It's got a raised slot, as we can see it's raised here, and then we've got a hole sitting sort of into the wall of this object. It's a really odd part, and if we were going to show the section view of all of this and remove the wall that's covering it, we would have to kind of jump back and forth between these three different center axes of these circular features. It does have two lines, and notice how much it kind of moves around. And notice that where it cuts and changes direction, we do have an object line going through the section lines. Auxiliary views. This is when orthographic projections of an inclined surface don't show it very well, and it creates what's called like a foreshortened view. And we want to look at that diagonal view straight on so we can see it in its true size. So this is an odd shape right here. It's kind of hard to tell what it is because of how it's angled. So notice we have a circle right here, and we can see that that's a circle in a circular view. But I wouldn't be able to put any like plus sign center lines in the other views for the other circle because they're only showing it as an oval. This is like a bracket, so it's like we've got a bracket. So here's the bottom of it, and then here's the side of it. But instead of being like a normal 90 degrees kind of bracket, it's actually sitting on it angular. So it's not sitting like this, like a normal bracket. It's sitting diagonally on the face of the bracket. So if there's a hole on this face right here, then I'm not going to be able to show that hole that's on that feature as a, I don't know why I pointed to it with my finger, as if that shows, so I was pointing to this. So I can't show this as a hole in any of the other views. So because it's foreshortened, which means this diagonal edge here, I'm always seeing it still diagonally to my eyes. I'm never seeing it straight on. So in the top view, I'm looking at it from, so in the top view, it's like I'm looking at it angled here. And then when I turn it to the front view, I'm looking at it angled. And when I turn it to the right view, I'm looking at it angled. I'm never getting to look at it square, where I can see the circular face. And that's what an auxiliary view is going to do. So if I move forward here, these views are foreshortened. So if I were to take the bracket where I'm seeing it as an angle and just rotate it off of that direction, I would see the front face. And that's the idea that's happening here is, and if I could show it to you on Inventor, we could learn it a little bit better. But so I'm trying to explain it as best as I can here. This gives me the actual true height and the true auxiliary distance here. And then I can actually see the circle as a circle. And then I can now dimension it. Because remember, you can't dimension circular features in any other view except for the view where they look like a circle. So in this view, it looks like a circle. So now I can put like the dimension of the diameter and the dimension of how far it is from each edge so that the person who's going to drill that hole knows exactly where to drill it. A detailed view, basically, if you were to know what a detailed view was in a short sentence, and that would be a zoomed in view. So it's an enlargement of something that shows details. Like for instance, if I were to dimension this, it's got like a bunch of little, it's like a Lego block or something. It's got a bunch of little circular features on it. I would just want to zoom in and show one of those pegs and then dimension it. So in the example here, it has a rack gear. A rack gear is instead of a circular gear that spins, the circular gear spins on this rack gear right here. and it moves it kind of in and out. So as the gear spins, it moves it in and out. Think of it like a DVD tray, a CD tray. They use rack gears. Anything that kind of has rotation, but then something moves straight out from it. So when I dimension this, especially when I look at it in the top view, it looks like a mess. When I try to dimension the size of these teeth, they are relatively small compared to the entire gear piece. So if I do a zoomed in or a detailed view, then I can dimension out the teeth so that the machinist can now come and cut out each one of the teeth. So that's the end of the slides. I hope everything is doing well with you guys at home. Keep these notes, and next week we're going to draw some of these section views ourselves, and I'll have a video posted for that for next week. The notes that you're taking, you're going to hold on to, and then when we meet again at school, like I said, we'll add them to our notebook and I'll look at them then.